Happy Wednesday. So tonight for the webinar, I was thinking about protein. And I wanted to talk about protein from a different perspective, meaning I wanted to talk about not just really why we need it or the importance of it, because I think we all know that, right? I think we all know that we need protein in our diet, blah, 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 for muscle building, energy, blah, we know this. Like anyone who follows any sort of nutrition, healthy practices, they know the importance of protein, right, that's understood. But I don't think many people really understand why behind that, right? So, really, what is a protein? Many people don't know that. And also how our body actually makes protein, because that's very important too. So that's what I wanted to talk about tonight in tonight's webinar. So there really when I posted the other day, I don't know if anyone saw it, on, I think it was Monday or Tuesday, I said, I'm not one of those people that track how much protein I eat, right? And I don't know if any of you do or if you find benefit in it, but I personally don't, and I don't think you really need to, because the truth is protein isn't everything you eat. So how can you realistically track it if it's in everything? That means you're literally looking at everything you're eating and seeing how much protein you have. And that means you're basically just tracking macros for all your foods. And for some people that works, but for a lot of people that's just not feasible, because that's just like you have to constantly be paying attention to all the food you eat. And that's not what I do, and that's not what I teach either. I teach intuitive eating through both my coaching and also my nutrition courses, because that's what I found works for me, and that's what I find works for my clients. So through intuitive eating, that includes obviously how much protein you eat, and the reality is your body knows how much it should eat based on how much food you eat and how you feel on a day-to-day basis. And if you have more questions about that, you can let me know, or we can discuss one-on-one, and I can talk more about that. But for tonight's purposes, I wanted to talk about protein in particular, but not really why we need it, but really what's happening more internally with our body. So because you're getting protein from literally everything, so it's hard to say how much is too much, too little, because the reality is if you're eating food, you're eating protein, because it's in everything. But technically there's two different types of protein sources from food that nutritionists and food people like to classify protein as, and that's complete protein and incomplete protein. Now, I don't like that terminology at all, because for me, it kind of assumes that maybe incomplete's inferior, and in fact, that's not true at all. The only thing between complete and incomplete protein sources is that complete proteins contain all the essential amino acids, and incomplete proteins might lack like one or two essential amino acids, but that does not mean that they're not good for you and that you should not eat them. So like complete proteins are like your meat, your seafood, your eggs, any animal-based foods. There's a lot of non-animal based foods like quinoa, buckwheat. There's also nuts, seeds. Those are technically complete proteins because they contain all the essential amino acids. And then you have your incompletes, which is just lacking, which is basically any plant-based food is incomplete, which we know we need those to eat. So why would they be inferior, right? So you really need a mix of all of it. And if you don't eat meat, then you have to really make sure that you're eating a variety of food to get all your bases covered, blah, 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 right? So then you're talking about, okay, what's in amino acids? That's really the crux of why we're eating protein. We're eating protein for the supply of amino acids. That's it, okay? So amino acids are the backbone to proteins. So our body is basically wanting protein in order to get the amino acids from them, because we're using amino acids to make our own proteins. That's the importance, right? So real quick, I do want to kind of talk about just what protein looks like, and then we'll get into how our body actually makes them. So again, the definition, basic science chemistry definition of a protein is literally any molecule that's made with amino acids, okay? and they're like in a chain. So you have one connected to one, connected to one. So there literally is a chain of amino acids all lined up together in a big chain. They're not branched off. They're not made in these big, like, other more complex molecules. They're literally in a chain, all linked up together. And what makes proteins distinct is that there's like thousands, hundreds, thousands of amino acids all linked up together. So when they all come in, what ends up happening is these long chains actually become these big conglomerate structures because they all kind of fold up in themselves. So proteins in themselves are these really big molecules, and they're all chained up in these amino acids. So when we talk about essential versus non-essential amino acids and making sure you're getting your essential, blah, 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 that's because all proteins are made of amino acids. So when we talk about essential and non-essential, what that's telling you is the essential ones are the ones that your body cannot make, and the non-essential are amino acids that your body has the ability to make. So when we start talking about getting all your essential amino acids, what that means is making sure you're eating proteins or amino acids that are in that bucket of essential, because that means is your body doesn't have the ability to make them, so you have to get them from an outside source. But there's only like 9 of them, so there's 20 in total, but the 9 you have to eat. Those are the essential. The other 11 are considered non-essential, and those ones your body actually has the ability to make, right? So what they are, you can Google what they are. Actually, I honestly don't really remember what the difference is. I probably knew at some point in my chemistry life, but it's nothing you really need to know. You just have to know at the end of the day, eat a variety of food, your bases are covered. Okay, but at the end of the day, protein is just a link of amino acids. They all kind of combine, glomerate up, fold up into like these big structures, globs of proteins that are really, really big. So I always tell people proteins are really, really big things in comparison to like the sugars that we eat or even the carbs that we eat. Those are actually really small molecules in comparison. Proteins are really, really big molecules, and your body is literally made up of like a million different types of proteins. So our bones have different proteins, our muscles are different proteins. I know a lot of people, they think the protein conversation is usually related to muscle building, but yes, that is true. Your muscles are made of protein, but so is your skin, so is all your organs, all your tissues, your hair, your nails, literally everything. Any structural piece is protein. Your blood has proteins in it. Everything has proteins in it, so they're all different. So because your body is constantly rebuilding itself every single day, you need to make sure your body has the ability to remake these proteins every single day. Hence why you have to have the constant influx of amino acids every day in order for your body to be able to make them. And where you're getting the influx of amino acids? From eating protein. That's why we're eating protein, is for the influx of amino acids. Because once your body breaks this down, literally it's kind of going in the reverse during digestion. So then it's just breaking it apart back to the individual amino acids. They get sent off to your cells in order to reform back into proteins for whatever protein your body needs at that moment, right? So hopefully that makes sense. Let me know in the comments or whatever if you want me to help you with that a little bit. But that's it. That's why we're getting protein. So now I want to talk about how our body is actually making proteins, because I find that very interesting, and I've noticed that my students and anybody who I've taught this to, it's one of the things that they actually find really, really cool, because it kind of puts all the pieces together. So hopefully my eraser is kind of wrapping out. Yeah. I'm always afraid I'm going to knock this board over. It's like kind of half-assed standing up at the moment. The legs are actually broken, so at any moment it probably could just topple right over. Hopefully not. So, again, we're eating protein for the influx of all the amino acids in order to make proteins in our body that literally make up everything in our body. So we'll go back to kind of bio 101. If there's anybody watching who's a bio major, you already know a million times more than me. I know enough to get by, and I know enough to kind of teach people the gist. So bring it back to biology for a second. We are made up of cells, right? All of our tissues are made up of different cells. And if you remember, inside of all of our cells is the nucleus, right? That's what's in the middle of our cells. Inside of our nuclei in all of our cells is our DNA, right? So we all know what DNA is, like genetics, it's in all of us. We know how important it is, but really not many people know, unless you're a science person, what DNA actually is doing. So really what DNA is actually doing is giving the instructions to make all the different proteins in our body. So each cell obviously has different DNA in it that's giving instructions for a specific set of proteins. So inside of our cell, inside the nucleus, is DNA. Now the thing about DNA is, because it's so important, it does not like to leave the nucleus at all. It's very, very important, because the DNA has what we call the code, the code, right? But really what the code means is the instructions, the instruction manual to make a protein. Okay, so the DNA is very important because that's what's coding for all the proteins in our body. So if the DNA is going to miscode or give false instructions, what do you think is going to happen? It's going to make the protein incorrectly. So if a protein's made incorrectly, then think, well, then what will happen? Something bad, probably, right? So mismade proteins, if your body does not destroy them internally, could be made into things that are really, really harmful for our body. It could lead to disease. It could lead to cancer, right? We don't want that to happen. And the thing is, it doesn't take a lot for proteins to be made bad. We talk about how there are long chains of amino acids. If even just one amino acid is wrong, it could be enough to screw up the works, right? So we really want to make sure that the DNA is coding correctly and making the proteins in the correct order that they're supposed to be in, because that's so crucial. So if the amino acids are not made in the correct order, the protein is made wrong, and then it's just a domino effect of wrong things, right? So we don't want that. And again, it only takes like one. So it's actually really, really specific, and it needs to be made properly. That's why the DNA is so important, and that's why it's kind of in its own like little shell of the nucleus of the cell, because it's so, so important. So then, the DNA has the code. It's basically like in its own little home here in the nucleus, but the proteins are actually made out here in the cytoplasm of the cell, like the gushy layer outside the nucleus, right? That's where the proteins are actually made. So if DNA does not leave the nucleus, so then how is it giving the instructions? What it does is it copies itself, and it makes something called a messenger RNA, okay? Or mRNA. Now, what DNA is literally doing, it's giving a copy of the instructions to the messenger RNA, right? So even think about it like in old school terms where you're given like a letter to like the messenger, and the messenger is sending it off to somewhere, to the person it needs to be, right? That's literally what the messenger RNA is doing. It's delivering the message, the code, the instructions of the protein somewhere else. So it's taking the code, the message from the DNA, and it's leaving the nucleus, okay? Because the DNA is really happy. It has the code. It's really, really important. The DNA does not leave the nucleus. So it gives the code to the messenger. The messenger now can leave the nucleus and go into the other parts of the cell, okay? So now the messenger RNA is outside of the cell. What messenger RNA now does, it attaches itself to another piece of the cell called a ribosome. So the messenger RNA literally just like attaches itself to this ribosome, right? But it has the code. It basically now has the instruction booklet. So literally it's attaching itself. It opens up the booklet, the booklet of the instructions, kind of like a cookbook if you want to think about it that way. It opens us up, it's kind of sitting there waiting like, okay, I got the instructions, now what? Someone's got to read them, okay? So who's reading the instructions? Oops. Come on, I can't spell. Okay. Something called a transfer RNA. I'm looking at my camera to make sure that's coming out right. I apologize. So the messenger RNA has the instructions. It's sitting there waiting with the instruction booklet. Remember, the instructions are how to make a protein. So the transfer RNA, or the tRNA, is the thing reading the instructions. So it comes around, looks at the instructions, goes, okay, I'll do this. And it comes and it's bringing all the amino acids together, and it's putting them together one by one by one by one in the correct order based on the instructions. So with the transfer RNA is the pool of amino acids. It's literally reading the instructions, and then based on what the order that the instruction says, it's just putting the amino acids together one by one by one by one based on the order. Once they're all lined up, then there literally is, you know, something that says, okay, we're done. There's an end code, so it, you know, terminates it, and then now you have a long chain of amino acids. They detach, they fold up into the protein, right? That's it. Super easy peasy. Again, you know, you can get a little more technical than this, but this is basically the gist of how our body's making proteins. So again, we're eating protein for the pool of amino acids, okay? We're, in order to get those, you know, because our body is constantly making proteins over and over and over again, we need a constant influx of amino acids. Where are we getting them from? The food that we eat, the real food that we eat. No matter if it's a plant-based food or an animal-based food, it doesn't matter, right? As long as you're getting a variety of food, you're getting a variety of all the amino acids, so your body has all of them it needs to make all the proteins for our hair, for our eyes, you know, for our skin, our nails, our muscles, our tissues, everything, okay? So you always got to be thinking about that, okay? Where's all the proteins made? In all of our cells. Obviously, your muscles is making its own proteins, right? Your blood's making its own proteins, so everything is constantly making it, and this is basically how it's done, okay? See, now you know. That's really it that I wanted to talk about today. This is kind of actually like a little preview of even the stuff I talk about in my nutrition course. I actually don't get this chemistry heavy in my online nutrition course. I more or less just talk about how your body digests everything, and then where it goes, and then what your body actually does with it, which is very fun and very interesting as well too. So if you guys are interested in knowing more, or even just more of the chemistry stuff, and it's not so hard, right? I teach it for everybody. You can sign up for my own online nutrition course. I have a wait list there right now. You can either message me privately or message me here in the comments, and I'll send you that link, or you can just go to my website and you can see the link at the top, and you'll just click into the waitlist. The waitlist is free. It's just as soon as I set dates, I'll let you know. You'll be the first one to know. That's basically it. So I hope this is helpful. And if you guys have any questions or comments, please feel free to comment below, and I will make sure I check, and I'll answer whatever you want to know, whether it's about this stuff or proteins or anything. I really don't care. I'll answer anything you guys want. Alright, hope you guys have a wonderful evening, and I will see you same time, same place next week. Bye.